Welcome back to episode 3 of a standard moon series. All right, so I ended the last episode in a mining run, and so let's go ahead and build a few things here. So my focus now is to put in some passive cooling into this room, and so it'll run manually initially, and then I will automate it. And so, for example, I'll use a gas valve for turning it on and off. Once I have the other alloys I need, I can put a digital valve in there. I'll have a simple pipe meter for reading the temperature, and later I'll go ahead and put in a pipe analyzer. So everything you see here can be fully automated. So what we're going to do is pretty simple here. I'm putting some extra piping here so I can put all the equipment. So for example, this will have initially the pipe meter, long term the pipe analyzer. And all I'm going to do is effectively just take the atmosphere within this room and put it in the pipe, with a passive vent, and then on the outside drop on radiators. And so basically the heat in here will just radiate out. And no AC required, should be a reasonably low power draw. Unfortunately, the integrated circuit housing requires 50 watts. So there's some draw, but it's a little more compact, and you don't need an AC. And since I'm not using an AC, I don't need like extracting like CO2 for a mixed gas. It also has a design for freeze protection, which I'll go into once I get it built out a little further. So and the freeze protection is, so let's say you have a bunch of pipes outside full of, say, CO2, and they radiate out, and you hooked it into like an AC wasteline. And if for some reason you sort of have to balance this, because if the AC doesn't put enough load on that wasteline, the temperature in that pipe will keep dropping until the whatever gas you have in there turns to liquid and freezes. Both in a gas pipe is a bad thing. So the problem is, how do you protect that from happening? And as I discussed before, while you could use the extending radiator, but unfortunately that requires super alloys, so it's a little difficult to make at the beginning. But this has the same type of protection built into it. If you have and you can run it just manually, fully manually, and it just means the temperature, goes up and down a couple centigrades as you turn it on and off in working the equipment, but then it can be fully automated later. All right, so when you go outside and put the outer part hooked in there. Now, if this setup doesn't radiate enough heat, in other words, if this is going full bore, and once again, I'm using the ones that radiate, not the convection, because this is all vacuum. If you use convection, this will not work very well. The other thing I'm going to do is I'm going to use one of these radiators, why I made an extra one, and I'm going to stick it on this tank here to start cooling it down. Now I have to keep an eye on it. It's a lot of gas in there, and with just one radiator on there, it's not going to cool very quickly, but I can start that process. So I have to make another pipe meter so I can stick it on there and easily read it. And then we're going to make sure we get all the gas out of there, because when you have just residual amount of gas, that cools down very quickly. Once again, forming liquid. I'm not sure what happened with liquids in a furnace. I don't know if that hurts it or not. All right, so we turn it on, and no, it's not an instant, drop the temperature down, but it will slowly reduce the temperature. Oh, so with my helmet off, in the tool printer there is a headlamp helmet. I've never actually built one of those before, and I didn't realize it until after this episode. So the beginning of episode 4, I will make a headlamp helmet and put that on when I have my normal helmet off. So that should help with the lighting. Also planning on putting some wall lights on, but I don't actually get to that in this episode. Here I'm printing off a couple of pipe meters. I'll put one inside and one outside. Now it's not technically inside because it's on the other side of that valve. And as you notice, the room has already dropped 1 Celsius. And because this room naturally warms up, so not only is it keeping up with the various things that heat up this room, but it also is able to drop the temperature down, and the fact that it's operating slowly is fine with me. And if it's not enough, I can always put more radiators outside. So we'll expand that little network of pipes, and we'll just double the radiators out there. I just want just enough radiators to slowly drop it down because I'm running it, say, in manual mode. And if it starts slowly heating up, then we know it's not enough. All right, so this is the protection in case of freeze. Now this should never be required, or it should never turn on. It's sort of a safety mechanism in here. And so what happens is, so let's say this room hits a target temperature and I close that valve manually, or in the future have a digital valve that closes. Well, that gas outside will continue to cool. And if I don't open the valve and bring in more of the gas from here to heat that back up, it'll keep dropping and dropping, turning into a liquid and freezing at some point, which is bad. I don't want to put a drain on there and just vent the liquids outside. That's wasteful. So what will happen here is, let's say that this is more for automation. Running it manually like now, it's not going to hit the condition, but I'm setting it up just so I can show you how the design will effectively work. I was thinking about throwing that oxide in here, but I didn't want to distort the passive cooling system, and it's kind of dropped to 31. If I'm close to it, it's 31. I think, yeah, there is 31. It needs to work its way through the room. Now you can put a bunch of pipes and vents in here, but this is fine. All right, so let's say that valve closed for an extended amount of time. I'll have a pipe analyzer on there, and the logic will look at the temperature. If it gets too cold, the pump will kick in, pump all the gas out of that outer pipe into the room, and that pipe becomes a vacuum, and voila, it can't freeze. And so that's sort of like a poor man version of an extending radiator. You just empty the pipe out. Now it does involve a little more interesting logic, but so that's, and I can do it manually now. So if I close that valve, I can just turn the pump on and create a vacuum. And since I have the pipe meter there, I can look at it and I know when I have a vacuum, and then I can just turn off the pump at that point. But with automation, that can be all handled automatically, and the pump only needs to run if the temperature in there will drop below some threshold. So if it just drops a little bit and it stays, let's say it drops to 10 centigrade, it's fine. You don't need to run the pump. But say it goes below 10 centigrade, you go, well, okay, this for some reason we're not putting enough stress on this, so we're going to go ahead and run that pump. All right, so we have that one. This should be emptying out here. We have that one pipe radiator just to start, bringing it down to a more reasonable range. We want to use that gas at some point. We might as well just slowly cool. And it's going to be a slow process, so we can always pop that off when we get a little too cold. All right, so I need to make my N bar and constant N. So I don't really have much copper, because I need copper, and I have the nickel. I need copper, nickel, and iron and nickel. So I figure go ahead and mine and get some copper and get some a little more oxide, and we'll maybe grab some more volatiles, so we have plenty of gas to fire up that furnace. So that's what the mining run primary purpose is. And then once we get those two, that covers all the alloys. Now we can upgrade our printers. We can get a heavy mining tool. We can upgrade our mining belt and tool belt, and get an arc welder. Well, you get an arc welder without that. We get the arc welder too, and then you get the color ore scanner. The color ore scanner I might be able to get already. So that droppage, I don't know if you saw when the ore just kind of dropped, it's more so because of, I think it glitches every now and then. That's that updating because I'm mining it so quickly. We're going to grab a little more volatiles over here, and we'll run across the top of our base. Yeah, my jetpack is doing reasonably well. We're going to have to worry about that. What I think I'm going to do is I'm just going to go ahead and put a filtration device on my waste gas, my furnace gas I have sitting out there, and say, I don't know. Typically I just use the CO2, but I can use that for the room for hydroponics. So maybe I'll just put pollutants in there and run my jetpack off pollutants. That should be fine. I'm kind of worried if I get the pressure over 5 megapascals, it may turn to a liquid, and that won't be too good. If I keep it hot, it's nice and hot now, so it's probably won't get too cold. Anyway, so I'll figure something else. There's ice everywhere, so it's not like finding something useful to fill up my jetpack. It's going to be a problem. Could just put a pressure regulator on there and just take the raw gas and just pump it into a container. It doesn't, as long as I use it outside, it doesn't really matter how hot it is. Okay, so let's see what we see here. We got everything ready. We're gonna, once again, we're kind of playing monkey here, and we'll just figure we put 7 oxide, we'll put 14 volatiles, we'll hit the button a lot of times, fire this thing up, let it melt, let it get up to temperature, and if it's not good enough, then we'll just add some more. So what you do is you shoot for the constant N first, because it has a temperature range of 1 Kelvin, 1 kilokelvin up. So it has no maximum. So you can make it as hot as you want and go from there. It does have, and pressure range is 20 megapascals up. Okay, so that was easy to do. Just crank it up, you get enough in there, pressure's up, and if the pressure is slightly low, when you throw in the ore, if it hasn't been degassed, it will help a little bit. And in this case, not having it, here I am trying to lower the temperature a little bit because I got a little too hot. NVAR has a range of 1.2 kilokelvins to 1.5. We'll just take advantage of it being a little too hot to get a little smelting done here. Running out of things to smelt. Now it's going to drop on its own, especially being that hot. So once we get it within range, I figure I'd take advantage of some free smelting. All right, so we're reasonable. We'll get this ore in here. We'll start the pumping. Fortunately, that pump doesn't go too quickly, so it makes it a little easier. Now we just have to wait till it drops below 20 megapascals. And then boom, we have INVAR. So that wasn't too bad. It's more finding the nickel than anything else. I lucked out and found a good batch of nickel. Fortunately, now I'm going to have to find some more nickel so I can make some super alloys so I can make my sensor glasses, or sensor lenses as they're called. And once you have that, now you're in magic land. Okay, so good. We have all the alloys now. Yeah, when I first started playing Stationeers, I would put off, making steel and put off making the alloys. And, once you get, stable, you're not going to die, you really need to knock those out. And I found just doing it over and over, just the practice of doing it makes it easier. Forgetting what the temperature range of a electron was. I had it written down too. I just kept swapping the two numbers around for Kelvin and Celsius. Okay, so we're going to upgrade electronic printer, which allows us to upgrade the tool printer, which will now allow us to make the heavy mining tool. Make another large battery for that. And that'll make mining a lot easier. As I said, I missed a few things I need to make in the next episode. I didn't make the arc welder, and I didn't make the ore scanner for color and all that. But we'll get to that next time. There's a little much going in my head. All right, so I figured while it's hot, let's just grovel through whatever we have left over, laying in the shelves, and smelt that up. So effectively, say we're going to upgrade the printers, upgrade our mining equipment, and then we're going to improve the power generation ability from solar. We'll put a solar tracker in the solar tracker is literally the same script I use for Vulkan. It seems to work fine for the moon, so. And we got a lot of time for that to drop. So I could put more radiators on there. I just put one just to, go down slowly. If you want to control that, if you had like, you tap into the data port and put a digital valve on there, and then just isolate it from the radiator. But once again, you got to deal with the problem of that remaining gas in there. So I guess if you could throw in a pump, but I think I'm going to try get that extending radiator. That seems pretty cool. All right, so you see the room. Brought the room temperature down, I mean, it's that little passive thing works pretty well for this current room. And it's that once I have grow lights, if it can't keep up, I'll just make it bigger out there. So, done. No AC, just plug that in, and boom. And instead of running it manually, I will automate that, switch out components, and then I don't have to worry about it anymore. Unless it's, I find it's getting too warm. We're just topping off our O2 and drop the pressure a little bit. All right, we got our update for our tool printer. Electronic printer, should I say. Now I can make this tool printer mod. We don't get to it this episode, but I will update the other printers too. Still working through the initial water and food from the lander. I haven't even touched the stuff, well, from the drop pod, we'll say. It's the lander itself, I haven't touched any of the food and water from there yet. Alright, so I think now you see it's heating back up in this room again because I have the valve turned off, which is normal. And then it gets a little too warm, I'll just manually, next time I come in here, I'll just open it back up, and or maybe turn it down. It takes a while to shift, so it gets a little chilly, I'll just turn it off. It'll auto warm up. I grabbed all those empty water bottles. I'm just going to throw all those in the furnace. I'm just not going to have stacks of empty water bottles everywhere. When I run out of water bottles, which is going to be a while, probably way before I run out of water bottles, I'll have a water fountain installed when I do the hydroponics. We'll throw that filter in there too. All right, so get rid of some of this junk laying around. Checking that, and we got lots of temp in there. Okay, let's do mining with the old. I think it's probably the last time with the old mining tool. And we're back. Just like I said, just a quick run because of, see if I can't get some of this copper. Just a quick run while we're printing off the tool printer mod. See if I get some free smelting in here while it's still warm. Okay, we're gonna just empty that sucker out. See what's going up here. Yeah, we're getting... Been thinking more and more about installing that solid generator up here as a backup. So once I add some more solar, I'm curious how well that keeps up. And turn that off. All right, so the room is 25. Okay, our target. So yeah, that little passive, that's all you need to do is just something like that. And so that's why the moon is fun, because you can, cooling is so easy. Just overcooling you got to worry about. Yeah, once I get my headlamp and some wall lights in here, then every time I come in, the suit will come off. And they have a suit rack thingy. I never made one before. And when you put your suit in the suit rack, it has connections that'll auto, charge and add O2 and dump your waste tank and all that magically. So, all right, so let's make something interesting. There's a headlamp right above me. I should have made that. Okay, I gotta dump all the crap out of the other printer and move it over. I'm doing this dumb thing where I'll try just put in the ingots I need. but it pretty much needs all the alloys because I'll make something else that needs it. So, oh well. So we're making our heavy mining drill. That will definitely speed up the mining runs. That's a big win there. Go ahead and make the, see, I need that other alloy. Should have just tossed it in there. All right. So we're going to make the mining belt. That gives us another row of room for ore in there. Went ahead and made a larger tool belt. Track down some iron. Move all the old stuff over. And we'll take this battery out so we keep that. And then we are done with the old mining belt. Let's just toss it over here somewhere and worry about it later. We got our tool belt. Let's see, we had 8 spots before. Now we got 10 spot for tools, but we have 2 empty spot for anything. So we gain 4 effectively, well, 2 dedicated tool inventory spots and 2 general purpose inventory spots. So definitely a win. Just looking at those, yep, I got to make some super alloys, which mean I have to set up the advanced furnace next, so I can do that. And we'll dump everything out of here. Yeah, I should have made a helmet and arc welder, but or helmet light and arc welder, but we'll get that next time. Could have made basketball, I guess. All right, so let's throw this junk back over here. Go ahead and make another large battery for the mining tool. It goes through power pretty quickly, so the goal is to keep 2 large batteries in the charging state, or minimum 2. So we'll just take this one and we'll flip it for a good one, and put this in our mining drill. And okay, so now that we have the mining tool improved, 2 directions I could go. One is I go ahead and print the advanced furnace now, but I decided right now to go ahead and improve my power situation a little bit. So I'm going to print all the junk I need to program ICs and housings and IC chips and some solar tracker units and all that. What I'm doing here is I'm just cabling this up. This is not really required per se. And this wire here is for put a wall light up there at some point. So I don't actually get the point of making a light. So the instead of running the cable down the center or down the roof line, which kind of is problematic because 1, you see it in the glass, and 2, I'll have sold units on part of the roof, and the wires will conflict. So I decided if I run them up the wall a little bit and put wall lights on the walls, which are called wall lights, and not put them on the ceiling, then put them on both sides, or at least one side, that would provide plenty of light in here. Before I realized they had a headlamp we can build. We'll try that one first. That one works well enough. We will probably defer the wall lights. All right, so I said I'm not going to mess with the laptop. I'm going to go ahead and just, for now, I'll reserve right to build a laptop later on, but I'm just going to build a normal computer station. Which is actually more of a hassle after doing it. You gotta wire it all up and all that, but oh well. So we need a programming chip for the computer. We need a housing so we can program chips. Now, if you're wired, you can sometimes program chips directly in other housings if they're all in the same network. And we're going to do another housing because on the roof where we're going to do the solar tracking, we got to have some place to put it. And we got to print up some more cables so we can wire that up. All right, so we're going to, so the room is down to 24. So we're just going to pretend we're automation here. And the valve is closed, so we're going to empty all the gas in that line into this room. And then once the gas hits 0, then we just turn it off. And in this scenario, we're going to be turning that back on soon enough. It's not going to be a problem. So I'm going to print up some solar tracker units and just going to throw a bunch of stuff in there so I can print a nice collection. I think I print 4 initially and get that going. And we turn it off. So now there's 0 chance if we just leave that as is forever, won't freeze anything on the outside line. Well, since we're kind of waiting for that print to happen, we might as well go ahead and try out our new mining tool. Yeah, when I put the advanced furnace in, I'm just going to take this furnace out, remove the pump since we don't need the pump anymore, but I'll leave the tank there, insulated tank behind it, and just hook all that up. Go ahead and top this off while we're here. Let's go look around for something interesting and try and get a little away from the base so we're not like, of course we find uranium. Wonderful. So we found a little spot and mine, or drill. So we're running at 5x as normal. Been finding quite a bit of gold, which is good. I haven't found any more nickel. I think once I upgrade the ore scanner tool to the color version, that should help. Once I figure out what color nickel is, I'll make it much easier to find it. And see, I got a hole. You see that hole? There's a hole right to the bottom. Like, you drill too quickly, find my way back out again. But if you drill too quickly down, you'll hit some kind of weird void. I assume it will fill in at some point. and then but I guess you could fall through technically. Grabbing some more coal because I'm kind of thinking more and more about getting that solid generator up there, so we'll grab that and all kinds of stuff. All right, so we got a whole bunch of junk. Obviously the mining runs are much more effective now. Not sure it's even worth getting the well, I need the I was thinking just go ahead and rush the sensor glasses, but I need more nickel, so I'm probably going to go with the color ore scanner to help me find the nickel that I didn't need to make the sensor glasses. Okay, we turn our beacon in. The room is still 25, so we're good. So we can leave that as is for now. But yeah, that little system's working pretty well to keep the room cool. All right, so we're going to take some of this excess ore and just put it in the shelves so I have some room to do construction work on the solar stuff. Taking some of the sub 50 units and putting it back in my mining belt. Okay, good enough. Still need to print some more stuff up for the solar trackers. Once that's typically set up, you know, then you just toss in more solar units. I'm building a APC, so the housing running the logic always has a stable power supply. We should never go to zero, but we'll just, it's not a big expense to set it up. Kind of think about what else do I need. Yeah, we're still going to wire up the computer there so I can program the chip. I can always reuse that computer long term for the satellite equipment. Yeah, in this run, I don't plan to rush trading, or given the seeds I started with, I'm going to avoid trading. Probably not have any trading in this scenario because I have 3 different kinds of seeds. I think that's more than enough to do useful things. Yeah, trading's probably the one feature I wish they didn't do. I know people like doing it, but just me personally, it seems like it takes out survival aspect. You just go ahead and, you know, trade for a bunch of stuff, and that's becomes more of a trading game than anything else. But everyone can play the way they want to, and if I don't want to trade, unfortunately, some things like Vulcan and Venus, you pretty much have to trade because you don't start with enough seeds that they give you a better selection of seeds. Then you can probably get away without any trading on those planets too. Alright, so we just kind of paste it in. This is, it's nothing fancy. So it's similar to other scripts out there. There's plenty of videos and scripts on how to do solar tracking on various planets and whatnot. I'm going to put this script in the description. The one requirement of the design is that when you place the dDaySensor, the solar tensor, you must place it flat, and the port must face north, which is coordinate 0 on the compass. But the solar units themselves can be any orientation. You just name them appropriately, and it deals with that fine. I always place my base in a certain orientation, so for me it's not a big deal with the restriction of the sensor. There are scripts out there that are more flexible, allows you to change the script to pick whatever direction it port picks. But okay, that's empty, so we turn that off. So we got to do some refactoring up here. Move this out of the way. Now, one strange aspect of having this nice glass on top is I don't have a lot of room, for a big array of solar trackers. Not without covering up, the blocking the view there. So what I'm going to do is I'm just going to end up, I got 4 right now. I'll end up putting, I think I can squeeze 7 up here. Now they do block each other a little bit when the sun is at, lower angles, and you don't maximize efficiency, but it's good enough. All right, so we're gonna put our APC here, so it'll get power directly from the output of the battery. I really didn't need to do that because that battery is never gonna be dead, but oh well. Little extra credit. And I missed. Okay, do that one right. We'll put a battery in there, turn that on, and then I go to close this, and not yet. All right, let's go ahead and mount the. All right, so this, we orientate this so the power port is a power port from the APC. And then we're going to put the sensor there. Just because I didn't like it next to the other one. Okay. So the sensor and the data port is on the main power line, or the incoming power line. So we can, but it does that because the solar units are on that same line. Because I have a limited number of, fortunately that's the airlock, and this is not a problem. I'm glad I didn't do that to the main base. Okay, let's try this again. There. But if our battery went completely dead, we would have enough backup power in the APC to keep driving this, so we would charge on the next cycle. So I guess you could argue it's a good safety feature. Well, if I went completely dead like that, I would just break out the solid generator and pump the thing up. Kind of think about how I'm going to run this line here, so we'll just kind of run it up here. Oh, and this script is designed for dual axis tracking, like Vulkan. It's an overkill for the moon, but it works, so why not? I didn't spend the time to rip out code and thin it down just for the this scenario. Just kind of looking which way that port faces. It's opposite, so it faces 180, and name all these solar 180. So internally it does a broadcast by type and name. So the name hash is solar 180. So it's sent out to solar 0, 90, 180, and 270. So that's a cool thing because you just place them any way you want to. So we'll just do this, keep the wiring down a little bit. And that will be solar 0. Now I'm just using normal cables because I don't have a lot of, each one, you can do 5 kilowatts, and each one of these maxed out, does 500. So, we're way below that limit. Because of the way this roof is, I don't have so much room on the roof. And so if I want to build a much larger array, I'm going to end up putting those somewhere else. I just can't think of any place to put it that doesn't look bad. I guess I could put it far away, but we'll go with this for now. And this basic one is just really, put the basic one over here just because I have it, but it really, really doesn't do much. And so I'm going to go ahead and once I have another of the better solar trackers available, I'm just going to rip this out and put this in a discard pile. Go ahead and clean up this wiring a little bit. Okay, so we got a lot more solar power coming in. That will take a pressure off of trying to keep that battery charged. See how well that does. All right, so we are at the end of episode 3 here. Things are getting better. We have our passive cooling system. We improved power. We got all the alloys and heavy mining tool. Until next time, see ya.